Good evening, Professor. I'm holding the camera like this because once I start recording, I can't flip the camera, so it's going to be harder for me to point at the slide and still talk over the camera and still see myself. So, my name is Kazi Ahmed. I'm taking Intro to Systems Engineering, your course, and I've done my report, and right now I've made the slides, so I'm gonna do my presentation, the 15 minutes, minimum 15 minutes presentation for the midterm report. And I have pretty much summarized the overall findings, the views that I've gotten, that I've found in different stages, such as the need exploration. I'm going to give a background and intro, and my the challenges, the system design, on the project that I've worked on, and finally I'm gonna finish up with my future goals, which would be what I plan to do more for the final paper. So what I've worked on is B-2 made by Northrop Grumman B-2 stealth aircraft. So my topic is a B-2 systems engineering case study. So like I said, my name is Kazi Ahmed, and my ID is N154-60597, and this is my presentation for the midterm report. And I'm gonna change the camera. Just gonna make sure you can see it properly. Hold it like this. So, like I mentioned, my name is Kazi Ahmed. My ID is N154-60597. Tonight's the 10/18/2019, and I'm gonna get on the next slide. So the next slide is it's the first. I'm gonna give a table of contents of how I plan to go about my presentation. So the first, I'm gonna have an intro, then I'm gonna give a background, then I'm gonna talk about the need analysis of that aircraft, which is the B-2 system. Then I'm gonna talk about the concept exploration. Then I'll get to the system design and talk a bit about it, and then the challenges. So this is not going to be an extensively detailed technically, because if I do that, then it's going to be an hour. But I plan to summarize it really well and give a really interesting overview of everything that I've found in an interesting manner. So still not boring to watch and to see. So first, like I said, it's my project. So I've decided to do research and do a systems engineering case study on the B-2 aircraft. So it's called the B-2 Spirit. It's also known as the stealth bomber. It's a very strategic bomber. It features low observable or stealth technology. It's designed for penetrating dense anti-air traffic defenses anywhere in the world, and it's still in use. So before I get to the talking, I am planning to show a video of how, if someone has no idea what a B-2 is, it'd be nice to see a video demonstration of how it flies. The sound. So this is a really excuse me, an HD video of its flying. There we go. It's been captured from a different aircraft while in flight, and I'll try to get to the cockpit part of it. So it's nice. Now it has landed. Sorry, the sound is really hard. And yep, they are. So it's been successfully landed, and they're setting up the part and putting in the shelter. And there's another video of how. So this video has been done in 2012 Air Force Global Strike Challenge, and it kind of shows you how a bomb gets loaded on the aircraft. I'll just quickly go over it. So these are very heavy, as you could possibly imagine. They're taken up on a different kind of cart and driven around. and gets to the receptacle part of the aircraft, and then it gets loaded. So there's that. I hope that kind of gave a more visual perspective on the aircraft. And I'm gonna get to the slides. So the stealth is one of the key factors required. Stealth is one of the key factors for establishing air superiority in modern warfare. So the bomber on this aircraft can deploy both conventional and thermonuclear weapons up to 500 pounds. It's primarily designed and manufactured by the main contractor, which is Northrop. Right now they're called, as of now, Northrop Grumman. The cost of each aircraft averaged at $737 million in 1997 dollars. But that's just the cost of aircraft. After, in another report I have mentioned in the paper, after the test, all the testing, the examining and everything, they come out to be 2.1 billion per aircraft. So the B-2 is the only US aircraft that combines the long-range stealth or low observability and all in a single platform aircraft, giving it the ability to project and utilize its power anywhere in the world under any given conditions. So before I move on to the other parts, I want to talk about what is stealth technology. What is stealth? So that's a picture of an B-2 aircraft. So it's scientifically known as low observability. It's used in military aviation, really, increasingly in various other projects. So it reduces detection range of an aircraft. It has partial invisibility of radar and other detection. It's very similar to camouflage tactics used by soldiers. And what is camouflage? It's pretty much using deception to walk into an enemy area, such as different colors, or just using or wearing clothes that kind of mixes along the area that you're in, so it's harder for enemy to notice where you are and detect. So it's just very similar tactics, but in a more technical way. So intro, I'll continue the intro. It says so 80 pilots currently are still flying B-2. They're still in charge. So each aircraft has a crew of 2, a pilot in the left seat and the mission commander on the right. The B-2 is highly automated, as one crew member can literally sleep, use toilet, make a meal, take a nap, while the other monitors the aircraft. Unlike most two-seater aircraft, where 2 people would constantly have to be in charge. So the background. So by the mid 1970s, military aircraft designers had learned a new method to avoid missiles and interceptors, known to as stealth. So the concept kind of came with the idea that to build an aircraft with a system or an airframe that either detected or absorbed radar signals in a way that almost nothing was sent back for the enemy radar unit for detection. So the B-2 originally came into existence to profit from the advances in stealth technology research that grew from very specific laboratory experiments, design studies that go all the way back to in the 1970s. So stealth offered a new and revolutionary approach for penetrating the sudden growth of the Soviet defense system mostly during the Cold War, in their very sophisticated radar detection network, which was very hard to penetrate initially. So the fighter was the first type of weapon system that studied the benefit of stealth. The bombers automatically the next promise, as the research was great and he was showing great promise. Northrop Grumman and Lockheed were competitors for the contract to develop stealth bomber in the late 1979, and during the 1980 was when the Air Force kind of gave the contracts for officially building B-2 aircraft. In the end, Northrop won the contracts to create and take control of the further researches. So the first flight of B-2 that was successful officially was in 17th of July 1989. It was a mission during the Balkan conflict in 1995. So now I'm gonna go over the need analysis in a very brief way. So that's a picture. It's a very nice HD picture of B-2. So the B-2, for the B-2, the DoD had already developed a mission area for strategic nuclear strikes that had bombers to the Strategic Air Command, or rather called SAC, and made stealth technology as their main primary operational strategy. So the government requested the industry to assess possible solutions for this missions in a way that they can come up with an idea or plan to combat that. So the contractor shared this responsibility. Both the government and the contractor personnel worked hand in hand as a team to derive the lower level requirements and to assess the effects of trade-offs in the top level primary objective and goals. So then we get to the concept exploration, where you have that picture which is a need analysis and the requirements, and they get to the concept exploration, and then from the need analysis using system studies you also get the concept exploration. So sorry for movements. From the very beginning, so the responsibility of requirement definitions at the operational stage and of the overall structure was pretty much divided equally from government and contractor, and it was very vital, as it sounds, very probably one of the most important part of the B2 systems engineering process. The government specified a broad set of essential performance objectives, and the competing contractors, Northrop Grumman, Lockheed, Vaughn came into play later. They wanted to take charge of it, and it was funded to pursue solutions to further allocate the technical requirements in a growing level of detail and complexity. As the more research was happening, as more work was happening, the more complex the overall system was becoming. And it was a very complex aircraft design. So that this process unfolded continually during concept exploration and eventually converged to a certain specification. So the concept exploration period of the overall B-2 program started when the Advanced Strategic Penetrating Aircraft, or called ASPA, studies were taking place. They were funded by the US Congress and the Air Force. The engineers and scientists investigated various techniques to avoid detection, and since 1940s. By the mid-1960s, Air Force Avionics Lab at the Wright-Patterson Air Force Base, they funded studies to develop radar cross-section prediction, computer programs, camouflage techniques, like I mentioned earlier, but in a technical way, models and materials and concepts. So the Northrop successfully came up with a plan, or developed rather, radar cross-section called RCS. They gave it a name. It's called GEMS-CAT, and had successfully predicted as a model the RCS for the F-4 fighter jet. But it was actually during the 1973 Yom Kippur War that kind of forced the need of stealth to come about and work as an operating system. Pretty much a sudden vulnerability of being attacked by ever-expanding Soviet air missiles and technologies kind of showed a new and sophisticated way was required to combat such attacks if one has to win, or rather even survive in a war against such technology. Shortly after that, Northrop and McDonnell Douglas received contracts for the work. Lockheed came to the scene after some time. So the conception of first Northrop B-2 stealth bomber program was funded by the Air Force in 1980s. It was during that study phase that for the main fundamental architecture of B-2 system was derived. The main decisions were based within the areas of radar, detection, navigation, cruise station, computer software, and data bus. So now we're going to get to the system design. So that's a picture of an aircraft, B-2. And this is a picture with specifically pointing to the different parts of the system. So I'm just going to quickly go over it. The stealth, as it points there, that's the radar detection avoidance technology. The weapons are loaded right there. 2 weapons bays within fuselage, each carry B-61 free fall nuclear bombs and 8 SRAM-2 nuclear missiles. The flight controls, which is all the way to the back. The crew is on top, a co-pilot, and a third crew member, and a second crew member to operate the system. The engines, it's right there, and the exhaust are the two dark patches. To give more detail about the system design, the B-2 weapon system consists of the B-2 aircraft, an onboard system that has a cockpit which accommodates a crew of two. It's equipped with color 9-2 electronic flight instrumentation, displays for the flight engine sensor data in real time to very precise details. The B-2 aircraft is a multi-role bomber capable of conventional and traditional munitions as well as nuclear munitions. Its stealth or low, or also called as low, observable characteristics give it the ability to penetrate in areas that are very highly sophisticated and have targets that are protected with the highest of security. So this is a picture, an architecture external diagram of the B-2 aircraft. That's the bottom, that's the front, and that's the top. And you can tell it's from the front view that how thin, as also I've shown you on the video, it's how thin and precise the design is. And this figure very nicely using being color coded. It tells you all the different surface parts that are designed by various companies, like the sides, Northrop, this two orange parts that are done by Vought. There's GE on the exhaust and Boeing in the three fundamental parts, with the crew station and the two parts of the main wing. Excuse me. So then I'm gonna now come on to the challenges and key results from the design studies that have been done. So Northrop, in the prime contractor for producing assembly aircraft, still face difficulties in delivering the B-2s that can meet Air Force operational guidelines that have to be met very precisely for obvious reasons, for safety and security requirements. Even after 9 years of work, when they started, for the most part, aircrafts were delivered late with significant deviations. The General Accounting Office, or rather called the GAO, observed that achieving the threshold radar level in order to go undetected was still a difficult objective to achieve. The GAO also stated that certain radar signatures for specified blocks don't really meet the contract specification, which can create erratic problems, aberrations from what is needed. And to continue with challenges, so the cost and development issues caused the overall price to rise significantly higher, which were also kept secret by the U.S. Congress until almost 1997. Investigative arm of Congress detailed in a week report that the B-2 world's most costly airplane. It breaks down in rain, in warm temperature, and high humidity. It has problem with the skin. The report said that by GAO that the skin of the plane can't handle high heat or damp or moisture for a long period. So without that, which kind of enables the stealth effect, the plane is less than unique technological achievement for Air Force than the Air Force that it claims to be. As a consequence, the plane requires very highly sophisticated climate control shelters, which makes it very difficult in a way where if an aircraft is to fly in an enemy radar and does its mission, but then it has to be sheltered for a while until it comes back and it needs to be refueled. Unless you have climate control shelters, it's going to be excessively difficult, which creates a problem and something that's still been worked on for better progress. And then I'm just gonna, since I'm over the 50 minutes, now this slide I'm gonna talk about the goals of the final paper, what I plan on working now, and the researches that I want to do more for the final report and what I want to accomplish. So I want to focus right now for the next part on the engineering development stage on certain criterias, the post development stage, the systems engineering challenges of the program, where the challenge was in terms of engineering in detail, and if it was resolved in a way that still met all the threshold values, or did they have to compromise in certain aspects, and the summary and the lesson that I've learned from studying this topic. So thank you. My email is right there, kaa532@nye.edu. I hope you've enjoyed my presentation. It wasn't too boring, and I kind of kept you on track. And I'm gonna flip the camera so you can see me. So that's me. Thank you for listening to it, and now I hope to work on my final report, and hope you like that too. Thank you.